Hello, welcome back. This is Miss Sheldon. Today we are working with pages 221, 222, and 223 in your notebook. So starting on page 221, we're going to be talking about the Pythagorean Theorem, which is something you should be familiar with from middle school. And what is the Pythagorean Theorem? Well, what it does is we can use it to find the length of the missing side in a right triangle. So here we have a right triangle. Let's go ahead and label our parts. So we have a leg here, and this is our hypotenuse. The hypotenuse is always opposite of this 90-degree angle. So the Pythagorean theorem only works for right triangles. And here, if we come over here and look at this diagram, we see that we have a right triangle in the middle, and off of each leg is a square. So if this side length is 3, 3 squared is going to give us a 9. So we have 9 blocks here. And then 4 squared is 16. So then this is going to be the same amount. If we add these two squares together, that's going to equal our hypotenuse squared. So I have 16 squares here. And I have 16 squares in this square. And then I have 9 squares here, and 9 squares in this square. So when we write that out, that can be written as a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. So a and b are the lengths of the legs, and c is the length of the hypotenuse. An important note here, when we have 3 whole number side lengths that form a right triangle, we call that a Pythagorean triple. I'm going to write that right here. Again, those are called a Pythagorean triple. So I keep saying this word Pythagorean, and you might not remember what that means. Well, it stands for the person who is credited with the Pythagorean theorem. His name was Pythagoras, and he was a Greek philosopher. And he was a mathematician. He actually ran kind of a cult that worshipped math, and we don't know if he's actually the one who proved the Pythagorean theorem, but since he was the leader of the group, he got the credit. And there's evidence that maybe Egyptians or Babylonians found the Pythagorean theorem long before his group did, but he's the one who has all the credit. So now let's look at these examples. So it says, a right isosceles triangle has legs 6 meters long. Find the length of the hypotenuse to the nearest tenth of a meter. So it tells us that the legs are 6 meters long each. So we know that both A and B equal 6. If we have 6 squared plus 6 squared equals C squared, 6 squared is 36. 36 plus 36 equals 72. And to solve this, we're just going to take the square root of C squared and the square root of 72. And that's going to give us about 8.5 meters. So now let's look at this one. So they tell us the hypotenuse length and they give us one leg, but they don't give us the other one and we're supposed to find it. So we have 8 feet, we're going to square that, plus this x value that we don't know squared equals 13 squared. 8 squared is 64. We're going to leave the x squared, and 13 squared is 167. When we subtract 64, we're going to get x squared equals 100 and, sorry, that's a 9, not a 7. When we subtract that, we get 105. So we'll take the square root, and we're going to get x equals approximately 10.2 feet. All right, now if you want to flip the page over, here would be a really good point to pause the video and try some of these on your own. So here they give us a rectangle with side lengths 4 inches and 11 inches and the diagonal. We see that this forms a right triangle, and this diagonal is our hypotenuse. So same thing, this is a side length, and this is a side length. So those are our legs, and we're trying to find C. So plugging that into the Pythagorean theorem, we have 4 squared plus 11 squared equals C squared. 4 squared is 16. 11 squared is 121. 16 plus 121 is 137. Take the square root of both of those, and the square root of 137 is about 11.7. So we have 11.7 inches. Now over here, they give us side lengths 8 centimeters, 10 centimeters, and 16 centimeters, and they want us to tell them if it's a right triangle. So we know that the hypotenuse is always the longest side of a triangle, so this number, 16, is going to be our C, and these are going to be the legs. So again, plugging that into the Pythagorean theorem, we have 8 squared plus 10 squared equals 16 squared. Now we're just checking to see if this is true, if this holds. So 8 squared is 64, 10 squared is 100, 16 squared is 256. 100 plus 64 is 164. And is that equal to 256? No. So, no. It is not a right triangle. So we can also use the Pythagorean theorem in the opposite direction. If a triangle is a right triangle, then we know that a squared plus b squared equals c squared. But we just showed that if we know that a squared plus b squared equals c squared, then the triangle is a right triangle. So our last example before we move on to the next note sheet. Here we want to find the distance between the points 4, -3, and -2, 1 on the coordinate plane. So we're going to start by plotting these points. So 4, -3, go over 4, down 3, and then -2, 1, go left 2, and up 1. Let's see if I can draw a straight line. So we want to find this length right here. Well, we can draw a right triangle and use the Pythagorean theorem to find that side length. So let's say this is a squared, or a, and this is b, and this is c. So a is equal to 1, 2, 3, 4. B is equal to 1, 2, 3, 4, 5, 6. And C, it's kind of difficult to count, so let's use the Pythagorean theorem. We have 4 squared plus 6 squared equals C squared. 4 squared is 16. 6 squared is 36. And then 16 plus 36 is 52. We square both of those. The square root of 52 is about 7.2. So this is where we get the distance formula. We have x squared, or sorry, not x squared, x sub 2 is what that's called, minus x sub 1 squared plus y sub 2 minus y sub 1 squared equals our C. Okay, let's move on to the next note sheet. This is at page 223 in your notes. So we can use the Pythagorean theorem to classify our triangles. So first we're just looking at the lengths of the sides. So if a plus b equals c, then that tells us that our side lengths are equal to the hypotenuse. So does that form a triangle? No. It forms a line. So it is a line, not a triangle. Because we have A plus B, and that's the same length as C. So those, as many times as you can try to arrange them, they're never going to make a triangle. So now, what if A plus B, what if our side lengths are greater than C? If they're not greater than C, then they're not going to make a triangle. So A plus B are less than C. It's not going to make any closed shape. So we have C right here, and then A here, and B here. A and B are never going to touch, and we're not going to have a closed shape. So if we have A plus B greater than C, then it is going to form a triangle. So now we want to know if it's an acute, an obtuse, or right triangle. So we're going to look at the squares of the side lengths. So is A squared plus B squared greater than C squared? If the answer is yes, it is an acute triangle. So for example, this is a triangle where all of the angles are less than 90 degrees. So let's go back up here. What if a squared plus b squared is not greater than c squared? So let's go down our flow chart. Now we want to know, is a squared plus b squared less than c squared? If so, it is an obtuse triangle. Here's an example. This is where one angle in the triangle is greater than 90 degrees. So what if that's not the case either? What if a squared plus b squared equals c squared? Well, after doing our Pythagorean theorem notes, everyone should know the answer to that. It's going to be a right triangle. So an a squared plus b squared equals c squared. It is a right triangle, which is where one angle equals 90 degrees. And we know this is true from the Pythagorean theorem. All right, that's all I have for now. Thanks for watching. I'll see you in class.